वेलकम यू ऑल। आज का जो लेक्चर होगा दैट विल बी फ्रॉम द चैप्टर वर्क एनर्जी एंड थ्योरम। इसमें जो एक इम्पॉर्टेंट क्वेश्चन है दैट इज वर्क डन, वर्क पॉजिटिव वर्क डन, नेगेटिव वर्क डन, और सबसे इम्पोर्टेंट क्वेश्चन जो है वो है वर्क एनर्जी थ्योरम और वर्क एनर्जी थ्योरम फॉर वेरिएबल फोर्स। वर्क एनर्जी थ्योरम फॉर वेरिएबल फोर्स स्टैंड्स फॉर कि आपका वर्क एनर्जी थ्योरम जो है दैट उसकी एक्सप्रेशन जो कैलकुलेट करनी है वो कैलकुलस बेस्ड होगी, यानी यूजिंग कैलकुलस मेथड। सो बिफोर दैट वी विल टॉक अबाउट द वर्क डन। वर्क डन का जो मतलब है लिटरल मीनिंग अलग है और इसका मैकेनिकल मीनिंग अलग है। इसकी जो फिजिकल मीनिंग है दैट इज फ्रॉम नेट डिस्प्लेसमेंट, यानी कि अगर आप नेट डिस्प्लेसमेंट जो है उस पर वर्क डिपेंड है। दिस इज मैकेनिकल मीनिंग और यू कैन से फिजिकल मीनिंग कि अगर किसी ऑब्जेक्ट में जो कितनी नेट डिस्प्लेसमेंट आई है, तो अगर आपका कोई इनिशियल पॉइंट पे कोई ऑब्जेक्ट है, आफ्टर अप्लाइंग सम फोर्स नेट डिस्प्लेसमेंट कितनी हुई है, दैट गिव्स द कंसेप्ट ऑफ वर्क। एंड वर्क इज एक्चुअली एनर्जी। हम वर्क को सिनोनिम्स टू एनर्जी, उसके बाद हम एनर्जी को इन टर्म्स ऑफ काइनेटिक लेते हैं या इन टर्म्स ऑफ पोटेंशियल लेते हैं। दैट इज द सम ऑफ काइनेटिक एंड पोटेंशियल एनर्जी इज द मैकेनिकल एनर्जी, एंड मैकेनिकल एनर्जी is responsible for creating or producing the motion in the body. That is, when body is applied with some force, obviously there is a net displacement, and that net displacement के लिए हमें कितना वर्क करना पड़ा या how much energy is utilized, that is known as work done. तो work is said to be done if a body is displaced through some distance, यानी कि वहाँ पे displacement आएगी। एंड सबसे बड़ी बात है इन द डायरेक्शन ऑफ अप्लाइड फोर्स। और यहाँ पे एक तो डायरेक्शन की बात भी आ गई कि द डायरेक्शन ऑफ अप्लाइड फोर्स एंड द नेट डिस्प्लेसमेंट काज्ड बाय दैट वेरी फोर्स गिव द कॉन्सेप्ट ऑफ वर्क डन। सो हम कैसे इसको एक्सप्लेन करेंगे? इट इज अ ब्लॉक, सिंस अ ब्लॉक ऑफ मास m एंड वी आर अप्लाइंग सम फोर्स F, और अब देखते हैं कि डिस्प्लेसमेंट किस डायरेक्शन में है। So here the main point, that is the direction of applied force and the displacement occurred. So you have to calculate what is the angle between the displacement and the applied force. So अगर मैं ये diagram बना लूँगा, जैसे block, say this is block of mass m and I create the force along this direction, force इस डायरेक्शन में, and displacement will be obviously along this direction. So there is an angle between this displacement, say x, and force applied. This angle is theta. यहाँ पे भी आपको मैंने परसों भी कहा कि you must be aware about the resolution of vectors. That is a very important factor. तो यहाँ पे भी अगर हम coordinate system डालते हैं, you see this y axis and this x axis. Along the x axis there is a displacement. You have applied some force F in this direction. A displacement occurs along this direction. Obviously, जैसे बच्चे टॉय चलाते हैं, रस्सी बांध देते हैं, फिर टॉय को ऐसे खींचते हैं, तो जो रस्सी से टॉय को ऐसे खींचते हैं इंक्लाइन पोजीशन में, और जो टॉय है वो जमीन से ऊपर सरफेस पे चलती है। दिस इज हाउ इट हैपेंस। आप ऑब्जेक्ट को ऐसे खींच रहे हो एंड वो ऑब्जेक्ट ऐसे चल रहा है सरफेस पे। नाउ दिस F इज टू बी सपोज्ड टू बी रिजॉल्व्ड। इस F को आप रिजॉल्व करो। दिस F with this theta, the adjacent angle at this baseline, this becomes F cos theta, and this will be here F sin theta. F sin theta यहाँ के किसी वेट के साथ या कुछ चीज के साथ बैलेंस हो जाएगा। Now you have a F cos theta and X in the same direction. So इस F का जो ये component है F cos theta, this is in the direction of displacement, and these two are parallel now. And the product of these two, that is F cos theta into X, is known as work done. This is the displacement, and the displacement is due to this force and the direction of applied force. This F into X, this F cos theta into X gives the work done. So you can write it WD is equal to F into X into cos theta. And you know from dot product A dot B is equal to magnitude of A and magnitude of B into angle of cos theta. So you have, instead of B you have X, instead of A you have F, and you have an angle between. So you can write work done is equal to F dot x. This is the work done, and the scalar quantity, the dot product of F and x, the dot product of force and displacement gives you the work done. You can have other components like this. If you have three components, Fxi is Fyg, Fzk dot, this is xi, x1i, x2g, and x3k. These are the components of x1i, x2g, and x3k along the three respective axes. The component of force along three respective axes. Then you can have work done is equal to fx1 plus fy x2 plus, yeah, this we can write x fz x3. These are work done along x axis. This is work done along y axis. This is work done along z axis. You write it like that. Fxi, Fi, can calculate this in terms of components. If you have a numerical given. So these are the three components the work done have. This force have along their respective axes. It is the work done. Displacement along three axes. So this is the actual formula that you have F into x is equal to cos theta. Now, value of work done will be maximum, minimum, and zero. हम लोग कैलकुलेट करते हैं when will be work done maximum, minimum, or zero. So you have to calculate the formula. W is equal to, work done is equal to F into x into cos theta. So if F, work done is zero, this condition, if F is zero, if x is zero, if theta is 90. The three cases when your work done is zero, because at 90 degree, at theta is equal to 90, you have WD is equal to F into x into cos 90, and cos 90 is 0, so your work done is equal to F into x into 0 becomes 0. So work done comes out to be equal to 0. That indicates अप्लाइड फोर्स अगर यहाँ से है और आपके या डिस्प्लेसमेंट यहाँ से है और अप्लाइड फोर्स यहाँ से है, then the angle 90 between applied force and displacement, the burden will be zero. There will be no burden at that very time. The burden is zero, and when displacement is at right angle to the applied force, या applied force यहाँ से होगा, displacement यहाँ से होगी, no work will be done. Second case, if theta is now the first case. The condition is if F is zero, burden is zero. कोई applied force नहीं है, तब भी burden zero. If displacement is zero, अब इस point का interpretation क्या है? If displacement is zero. Now, if x is zero, burden is equal to zero, stands for कि अगर कोई object move कर रहा है in a circular motion, and reach it to same point जहाँ से initial point पे पहुँच गया वापस, या ऑब्जेक्ट यहाँ से ऐसे मूव कर रहा है, फिर ऐसे मूव कर रहा है, फिर ऐसे, फिर लास्ट में वापस आ गया, या ऐसे मूव कर रहा है, ऐसे मूव कर रहा है, फिर लास्ट में वापस आ गया, तो नेट डिस्प्लेसमेंट इज जीरो. तो x is equal to zero doesn't mean the object is not displaced. X is equal to zero means if the object is displaced and it returns back to its initial point, even then burden is zero. But that means for any cyclic process, your burden is zero. Any object that starts its motion and reaches to its initial point, even though it travels this much distance, even then the burden is equal to zero, because at first point I said that burden is a mechanical concept. It means to produce net displacement. And there is no displacement, because the object returns back to its initial point, the burden is equal to zero. So this is the interpretation how x is equal to zero. Means the burden is zero. That doesn't mean that x is equal to zero, the object is not displaced. Object is displaced, but it returns back to its original position or its original configuration. When any change returns back to its original configuration, the net burden is zero. And when theta is 90 degree, means angle between force and displacement 90 degree, even then the burden is equal to zero. Now the second condition is, say suppose if the object is at some height. So suppose object is here. This is ground surface, this is earth, और ग्रेविटेशनल फोर्स ने अर्थ को अपनी तरफ खींचा. Gravitational force is attracting the object towards itself. और ऑब्जेक्ट डिस्प्लेसमेंट भी इसी डायरेक्शन में है. सपोज द चाक and gravitational force is moving it downwards, applying force to downwards, और चाक भी नीचे ही आ रहा है. तो डिस्प्लेसमेंट फ्रॉम दिस पॉइंट टू दिस पॉइंट, डिस्प्लेसमेंट भी नीचे की तरफ ही है, फोर्स भी नीचे की तरफ है. Do that indicates F is parallel to displacement. So that means theta is 0. Angle is 0 degree. When angle is 0 degree, when theta is 0 degree, this indicates that F is parallel to displacement. Both are in same direction. At that very time, cos 0 becomes 1. So your work done is equal to F into X, because cos 0 degree is equal to 1. So WD is equal to Fx is a positive work done, maximum work done. Can you take the example? Now the same example to gravity. This is work done by a gravity, this gravitational force, gravitational work done. Work done by this gravitational force. Suppose from the surface of Earth, if I throw the object upwards, so gravitational force is downwards, but object is moving upwards, so displacement is upwards, gravitational force is moving downwards. Here the displacement is anti-parallel to the gravitational force. Therefore work done is equal to, so here F into X into cos theta is 180 degree, because F and X are 180 degree. This is an example. When you drop the object, the gravitational force is downwards, your displacement is downwards. When you throw the object upwards, the gravitational force is always downwards, it's toward the center of Earth, but then you are throwing the object upwards. So the object is moving upwards, but the gravitational force is moving downwards. So the angle between F and X is 180 degree. That indicates this F and X are moving anti-parallel. So your work done is equal to F into X into cos 100 is minus 1. So you can write as minus F into X called negative work done. And this is known as positive work done. So you have 0 work done, theta 90 degree, 0 work done, theta 0 degree, you have a positive work done, theta 180 degree, you have a 90 work. Sorry, you have a negative work done. So work done can be positive, negative, or 0 whenever the object is moving at right angles to the applied force. The applied force is along the right angles with respect to the object's motion or its direction of motion. At that time there is no work done on the object. The work done is 0. If the applied force and object is moving in the same direction, or you apply the force along the direction of the motion, that way time the work done is positive. And if the object's motion is opposite to the direction of the applied force, that way time the work done is negative. So you take the example of the two. When you drop the object under the influence of gravitational force, with respect to the gravitational force, the work done is positive. And when you throw the object upwards under the influence of gravitational force, the displacement is against, or displacement is opposite to the gravitational force. At that very time, the angle is making between the F and displacement is 180 degree, and cos 180 degree minus 1. So your work done is negative. These are the work done positive, negative, and 0. So now this is a most important question. Work energy theorem. Work energy theorem by variable forces. Work energy theorem. Work energy theorem for a variable force. Work energy theorem. Variable force मैं क्यों mention कर रहा हूँ? Because you have to calculate it using calculus method. Variable force. Now, what is the definition for the work energy theorem? The change in kinetic energy is equal to, यहाँ पे kinetic energy का मसला है कि when you apply the force, the object is displaced. There is a change in kinetic energy because when you apply the force, say the object, it has definitely some velocity, say v1 or u initial velocity. After a moment, its velocity either changes or its velocity is changing, either increase or decrease depending upon the condition. So you apply the force, its velocity changes from u to v, and there is some mass m. The object has mass, and mass is not changing here. The object changes its velocity from u to v. When there is a change in velocity, obviously there will be one condition of kinetic energy, mass be same, there will be another value of kinetic energy. There is a change in kinetic energy. That change in kinetic energy is equal to the applied force. And that change in kinetic energy to be calculated known as work energy theorem. So यहाँ पे जो kinetic energy होगी, so you can calculate v square minus u square is equal to 2as. This is v square minus u square. This change in kinetic energy is an acceleration is equal to f by m into s. You can write m here, m v square minus m u square, and यहाँ 2 आ जाएगा. 1 by 2 is equal to f into s. This f into s is a work done, so you can have work done is equal to 1 by 2 mv square minus 1 by 2 mu square. This is also final kinetic energy minus initial kinetic energy. This change in kinetic energy is equal to work done. The change in kinetic energy is equal to the work done. This is known as work energy theorem, and you have supposed to prove that kf minus ki is equal to wd. So, but you are supposed to now calculate it in terms of variable force. If you have a variable force, if you have a constant force, I write E F by m. This is for condition for constant force. But if the force is variable, मुझे वो क्वेश्चन असल में डिस्कस करना है, बट टू मेक दैट सिंपल मैंने कांस्टेंट फोर्स पे अप्लाई किया कि मुझे असल में कैलकुलेट क्या करना है, चेंज इन काइनेटिक एनर्जी, फाइनल एनर्जी माइनस इनिशियल काइनेटिक एनर्जी, वो हमें कैलकुलेट करना है. दैट इक्वल टू वर्क डन. और ये जो है ये कांस्टेंट फोर्स के लिए. बट द क्वेश्चन दैट इज राइट नाउ वी आर सपोज्ड टू डिस्कस इज अबाउट द वेरिएबल फोर्स. सो वेरिएबल फोर्स के लिए हमें क्या करना है? We will not write the definition. So thus change in kinetic energy is equal to work done by the applied force. So we can write kinetic energy K is equal to 1 by 2 mv square. We know the kinetic energy K is equal to 1 by 2 mv square. So differentiating with respect to T, we can write dk over dt is equal to dy dt of 1 by m v square. You know 1 by 2 is constant, m is constant, you can write dy dt of v square. So this can be dk by dt is equal to this 1 by 2 m, this is x raised power n, d by dt of x square, that is x raised power n, or you can write v square becomes 2v, और v की जो डिफरेंस होगी that dv by dt. So this 1 by 2m, ये 2 नीचे आ जाएगा, into फिर v बचेगा, v raised power 2 minus 1 that is 1, फिर into v का होगा that is dv by, you know it calculus, 2 will cancel, so you can write dk by dt is equal to m into v. This dv by dt known as acceleration because dv by dt is known as a acceleration. And dk by dt comes out to be equal to m into a into v. This m into v according to Newton's law is equal to force. So you can write dk by dt is equal to f into v. You can continue with this. dk by dt is equal to f. I can write dx by dt because velocity is equal to change in displacement per unit time. I write this. So this dk and dk, you get dk comes out to be equal to f into dx. This is the small change in kinetic energy with this small distance dx. The change in kinetic energy is equal to work done. on the object by net force. So you can write it now. So this is a work done, sorry, change in kinetic energy, small kinetic energy with respect to small displacement made by the applied force on the particle or on the object. If on integrating these two between the limits, limits क्या होगा? You have an initial kinetic energy, an object moves to final kinetic energy, dk, and you have the displacement, initial displacement. You have f is say here constant. I can integrate it f into from initial displacement to final displacement xf into dx. Integral dk will be k from k initial to k final is equal to, this is xi to xf f dx. This is kf final kinetic energy minus ki initial kinetic energy is equal to xi to xf f dx. This is known as work energy theorem. This change in kinetic energy is equal to the work done on the particle by the applied force. This kf minus ki is a change in kinetic energy and is known as work energy theorem. तो ये था, this is a most important question for the board exam. This change in kinetic energy is equal to work done. You can write kf minus ki, or delta k, you can write it sometimes. Delta k is equal to k xi to xf f dx. You can also write like this. Thank you very much.